okay? And let's see if we're comfortable with this. They give us a whole bunch of functions, f of 2, f prime of 2, g of 3, g prime of 3, but look at what they're asking. They're saying if h of x is equal to this composite function, then find the derivative, okay? What formula are they getting at? The chain rule, very good. So if h of x is equal to f of g of x, then h prime of x, and it's good to keep the x in there, guys, because if you do, you know where to plug in the 3. Otherwise, it's hard to know where to plug in the 3. H prime of x is equal to, now guys, what's the chain rule? The derivative of the outside, now that's the product rule, derivative of the outside, leave the what? Leave it alone, guys, leave him alone, okay? Then multiply by the derivative of the inside, okay? Then what you do is you say, I don't really want h prime of x. I really want h prime of 3, okay? And the way you do that is everywhere there's an x, you're going to put in 3. Now, here's the thing. If you didn't write the formula out this way, what a lot of students end up doing is they put an extra 3 right here, but there is no x right here, okay? So there's actually only a 3 here and a 3 here. Then you go in and you figure out what g of 3 is. Do I know what g of 3 is? Am I given it? It's 2. So guys, this is actually f prime at 2 times what? What is g prime of 3? Negative 5. All right, now go find out what f prime of 2 is. What is f prime of 2? 1. So what's 1 times negative 5? Negative 5. Okay, for some reason, that was way easier than 4th period. Okay, you guys good with that? All right, let's go ahead and look at the derivative here. Now, to take the derivative of something, okay, what you will usually have is we usually have y equals something, okay, and then you'll say, okay, well, dy dx is the derivative of this, which is 2x. But what happens when you can't pull out the y? Because look, you have a y here and a y here. Do you remember we did explicit differentiation, but we also learned what? Implicit differentiation, okay? And so if you cannot pull out the y, what you have to do is just settle for taking the derivative of both sides, okay? It was a long time ago, okay? And so what you're going to do is you're going to take the derivative of the left side and take the derivative of the right side, set it equal, and do you remember you pull out all your dy dx's? Do you remember this? Okay, so do you see that this is just a string of things added together? I know there's subtraction too, but for me, subtraction is just adding together. You guys are going ahead of me. Okay, so you thought you got to do one problem, but oh boy, you get to do 3. Okay, so let's just do the first one. What's the derivative of e to the u, right? The derivative of e to the u. The derivative of e to the u is e to the u times something though, times the derivative of your u, okay? So let's do it. The derivative of e to the xy is going to be e to the xy, you just copy it, okay? That's your u, times the derivative of xy. Now that seems overwhelming, but let's just take it a step at a time. What is the derivative of x times y? Isn't that just product rule? Okay, so here we go. The derivative of the first, which is 1, times the second, which is y. Everybody good with that, right? So derivative of the first times the second. Okay, do I need a dy dx? No, because you just times the second. Does that make sense? I didn't take the derivative. Then you say plus the derivative of the second. What's the derivative of y? 1. But do you need a dy dx? Yes, because it has a y in it. So it's 1 times dy dx. I'm just going to put dy dx, so there's not too much clogging up here. So derivative of the first times the second plus derivative of the second times the what? First. All right. So this is the derivative of this first term. What's the derivative of x squared? 2x. What's the derivative of negative 2y? What's the derivative of negative y squared? Negative 2y, but do you need a dy dx? Very good. All right, I've done all of the left side, okay? Then here's the kicker. What's the derivative of 10? 0, very good. It is not 10 and it is not 1. Is everybody good with that? So then what you want to do is pull all the dy dx's to the left. But I have a little bit of a problem. I've got a lot of things going on right here. I'm going to take out the 1. You guys okay with that? Because y times 1 is just y, okay? And to pull the dy dx out here, it's kind of like a weird thing, but in order to make things more simpler, I'm actually going to have to distribute, because this dy dx can't be pulled out unless I distribute. So when I distribute, I get e to the xy times y plus e to the xy times dy dx times x. Do you guys see that? Okay, you just multiply them all together, but you can't really do anything, so you just put them next to each other, plus 2x minus 2y dy dx, which is equal to 0. Now, let's not lose sight of our goal. Our goal is to figure out what the derivative is, what dy dx is. So here's a dy dx, and here's a dy dx. Do you remember what you do? Very good. You move everything to the right side, pull all your dy dx's to the left side. But remember, if you change the side, you change the sign. Okay, you got to use real algebra. So let me just actually copy all the dx terms right here on the left side. These are the 2 terms I have that still have dy dx in them. On the right side, if I change the side, I'm really just subtracting it from both sides. I have to change the sign. Okay. Now, why did I do that? So that I could pull out the dy dx. So do you see I have a dy dx here and a dy dx here? When I say pull it out, that means I can factor it out. Okay, if I had other things, I couldn't factor out the dy dx. So that's why I only leave the terms with dy dx here. And then when I take out a dy dx from this term, I get exy times x minus, when I take out a dy dx from this side, I just have 2y left over. On the left side, I have equals e to the negative e to the xy times y minus 2x. Anybody have any idea how to solve for dy dx? Divide both sides by this big blue thing right here. So I'm going to divide this by e to the xy times x minus 2y. So let me rewrite it so it's a little neater. I have dy dx is equal to negative e xy times y minus 2x over e xy times x, and I think that's a minus 2y. Do you remember that from a long time ago? Okay, we added a little bit something because we learned it last year, the derivative of e to the u. We added that, but other than that, this is how you do implicit differentiation. Now you need to know that if this were a multiple choice test though, do you see how there are 3 negatives and just 1 positive? Do you see that? So a lot of times books will simplify this by changing every sign, okay? So if every one of your signs changes, okay, make sure you understand that is the exact same answer. How come you can change every sign and make that the exact same answer? What are you really multiplying by? Yeah, you're really multiplying by -1 over -1, which is 1, all right? All right, let's go ahead and do some review with you guys on tangent lines. Then I'm going to set you free to do your homework, and I'll have the solutions on the board, and you guys can check it as you guys go along, okay? What'd you say? Okay, here we go. You're so agreeable today, Kaylee. Okay, so find the equation of the tangent line, okay, at pi, and here's your function. All right, when I need an equation of a tangent line, what 2 things do I need? A point and a slope. So I'm going to write that down. And everything needs to be a number. So if I have an x, I'm going to have to replace everything with a number. If I have a y, I'm going to have to change that to a number somehow. All right, do I have a number for x and y? I do, so that's pretty nice. All right, now let's go for the slope. I need the slope of the tangent line. What did I say? I need the slope of the tangent line. What is that? The derivative. When I say derivative, you say slope of a tangent line. So guys, this is really just the derivative, okay? So y prime is equal to the derivative of this. Now this is really just 2 components. Oh boy, okay. So the derivative of x is 1, okay? This minus 2, are you guys okay? It's just a scalar, okay? So I'm going to pull out the minus 2 and multiply it by the derivative of sine x, whatever that is. Okay, now what is the derivative of sine x? You got to think, cosine x. Does it have a negative though? No, okay. If it had a negative, then it'd be -2 times -1. Do you guys see that? but it doesn't have a negative, so this answer is 1 minus 2 cosine x. All right, but the problem is my slope is not a number. How can I get it to be a number? Okay, so what is x? Pi. So I'm going to plug in x as pi. So what I really need to do is figure out what cosine pi is. Guys, if you have your unit circle, pull it out, see if that helps you. Because I feel like when I ask people for the cosine and sine values, I feel like you guys are just guessing. Okay, so this is where pi is. What are the coordinates for pi? Okay, so what is my cosine value? -1. So this right here is -1. Okay, now guys, multiplication before addition or subtraction. So you're gonna have to multiply by -2. So what's -1 times -2? 2. So do you see that's +2? Okay, and so my answer is 3. All right, so I've got an x in a number form, I've got a y in a number form, and I've got a slope in a number form. So you put it into the point slope formula, okay, which is y minus y is equal to the slope times x minus x. You just plug it right into this formula. So my y is pi, my m or my slope is 3, and my x is pi. Okay, and that is a great answer, especially if it's free response. Sometimes though, they'll ask you for y equals, and all that means is that you would add both sides by pi if you wanted y equals. Okay, this is the point slope form. Okay, and this right here is the, I guess you'd have to distribute it, but it would be the y, slope y-intercept form, okay, which is what you guys are more used to. All right, let's look at this problem right here. Find the x coordinate of all points on the graph where the tangent line is horizontal. When they tell you the tangent line is horizontal, let's think about this. What's the slope of the tangent line? If a line is horizontal, what's the slope of it? Okay, so if the slope of the tangent line is 0, what is equal to 0? When I say derivative, you say slope of the tangent line. So what is actually equal to 0 here? The derivative. Does that make sense? The slope is the slope of the tangent line is the derivative. Okay, so the derivative is equal to 0. Or you could say, you know, y prime is equal to 0. However you're making your notation there. All right. So what they're saying is, if the derivative is 0, okay, find what x is. That's what they're saying. If the derivative is 0, find what x is. Well, do I know what the derivative is? Didn't I find it right up here? Right? This is a derivative here. Now, don't plug in pi here because we're not using this point anymore. They're just saying, hey, go find this point if you know the slope. So the slope is 1 minus 2 cosine x. I actually don't need that parentheses, so I'll just say 1 minus 2 cosine x. And now I set that equal to 0 because that's what they're telling me. Now they're saying go backwards on this and go find the point. Okay, so now this is no longer the point. Go find the point. Really, it's just solving for x. So first of all, I'm going to try to isolate the cosine x. What do I do to both sides first? Subtract 1. All right, there I am. How can I still isolate this cosine x? Divide by -2. So what I get is cosine x equals 1/2. And we did this yesterday. This is always an angle, guys. Okay, this is always an angle. Okay, so if this is always an angle, you think about your unit circle and you go find what angle that your cosine value, so that's your x value, is going to be 1/2. So your x value is going to move to the right by 1/2. So where would those points be? Pi over 3, very good. And yeah, that was impressive, Christian. Okay, this one's pi over 3, that's a 60-degree angle. And this right here is a 300-degree angle, 5 pi over 3. So that is your x. X is pi over 3 or 5 pi over 3. And I stopped there. Of course, there's an infinite number, but do you see they said just to look at one circle. Okay, 0 to 2 pi. And those are your answers for x's. All right, we're going to do something similar in part 3. Okay, now they're telling you to find the x when the tangent line is parallel to this line here. Okay, so if you have this line here, so y equals x plus 4, that means the y-intercept is 4. What's the slope here, guys? 1, right? Because the slope is just the coefficient in front of your x. Okay, so that's the slope. So I'm going to go up 1 over 1, up 1 over 1. So there's this line like this. All right. I want to find all the lines, all the points where the slope is where the tangent lines are parallel to this line. Guys, if the tangent line is parallel to this line, what's the slope? What is the slope of two lines that are parallel? Yeah, it's the same. So if this slope is 1, okay, then the slope of the tangent line will also be 1. And guys, what's another name for the slope of the tangent line? Derivative, okay? So up here when they say the tangent line is horizontal, they're just saying dy dx is equal to 0. Down here when they say the tangent line is parallel, they're just saying dy dx is equal to the same as this slope, which is 1. All right, so I'm going to do the same thing I did up here, but instead of 0, instead of setting the derivative equal to 0, I'm going to set the derivative equal to 1. All right, so the derivative is, I've already figured out, the derivative is 1 minus 2 cosine x. You guys good with that? We did that in the first part. Okay, that's equal to 1. All right, now my goal again is to isolate this cosine x. What do I do to both sides? Subtract 1. Okay, again, I'm trying to isolate this cosine x. What do I do to both sides? Divide by -2. But what's 0 divided by -2? 0. So I get cosine x is equal to 0. Think about my unit circle. Okay, cosine x is equal to 0. At what angle? Because this is always an angle. If it's sitting next to cosine or sine, at what angle is cosine, the x value, meaning I don't move left or right, going to be 0? Pi over 2 and 3 pi over 2. Nice. Okay, so this is going to be x equals pi over 2, comma 3 pi over 2, and we are done. All right, I'm going to set you free. Okay, fly like a bird, people. Fly, fly. Your homework's going to be done tomorrow, due tomorrow. But some of you guys might finish it today. I'll check you off. And then tomorrow we're going to do tangent line approximations. I'm going to do number 5. So we're looking for the equation of the tangent line for number 5 here. You need a point and you need a slope. I already know the x value is 0. How do I get the y value? All I do is plug in 0 here, plug in 0 here. So what I get is a y value is 2 minus 3 times 0. That's not 30 because they're multiplying by 0. Times the cosine of 0. This is actually 1, but this is 0 times 1 times 3. So what you get is 2 minus 0, which is 2. All right, so there's your x and your y. I also need my slope. Okay, so how do you find the slope? The slope is going to be, here, I'll leave this. The slope is going to be the derivative. The derivative of 2 is just 0. Let me change this to 2 plus minus, like this. Okay, so it's going to be the derivative of 2, which is 0, plus. And then this is product rule here. So it'll be the derivative of the first times the second plus the derivative of cosine u. The derivative of cosine u, remember, is negative sine u times du dx. But what is my u here? My u is pi x. So this is pi x. This is pi x. And what is the derivative of pi x? What's the derivative of 3x? It's 3, right? So what's the derivative of pi x? That's not 3, it's pi. Okay, so right here, the answer is negative sine pi x times pi, but you can't multiply this pi with this pi x, okay, because the pi x belongs to the sine, but you can multiply the pi times a negative. So what I get here is negative pi sine pi x. All right, derivative of the first, where did I get the 0? Oh, okay, derivative of the first times the second plus derivative of the second times the first. All right, and I want to get this into a number. Let me go ahead and kill this 0. I don't need that. This is going to be negative 3 cos. So sorry, this right here needs to be done first. So this is 0. This right here is 0. And this is negative 3x, so this is a 0. Okay, so what I have here is negative 3 times the cosine of 0. Here's the 0 value here. So the cosine of 0 is 1. Okay, this right here is just, sine of 0 is 0, and then this right here is 0. Okay, so then all I get here is negative 3. So the answer here is going to be y minus y is equal to the slope times x minus x. Can you check that for me? Is this right?
Yeah.
The slope. What is my y value? My y value is x squared, which is pi over 4 squared, times sine of 4 times pi over 4. All right, but 4 times pi over 4, guys, this is really 4 over 1, right? So this is really just sine of pi. But what is sine of pi? If you look at your unit circle, pi is over here. And so the sine value is what? 0, right? So this right here is 0. So your y value is 0 times pi squared over 16, which is just 0. All right. What is y prime? I'm calling this y. Y prime is going to be the derivative of the first times the second plus the derivative of the second, which is cosine 4x times 4, right? So cosine 4x times 4 times the second, or sometimes the first. Okay, remember, because this is cosine u times du dx. All right, that's where this 4 comes from. All right, okay, so then every x is going to be pi over 4. So this is 2 times pi over 4 times sine of 4 times pi over 4. Well, that's just 4 times pi over 4. That's just sine of pi, right? Plus cosine of 4 times pi over 4. Again, that's cosine of pi times 4 times pi over 4 quantity squared. Everywhere there's an x, I'm putting in pi over 4. Okay, so pi over 4 times 4 is just pi. That's how I got this. All right, and then just figure out what this derivative is equal to. On the left side, this term that I have sine pi, what is sine pi? Think about your unit circle. Here's where pi is. Yeah, that's 0. So this whole term knocks out, right? Because that's 0. So over here, what is cosine of pi? So right here, guys, here's cosine of pi. Isn't that negative 1? Okay, so that's going to be negative 1 times 4 times pi squared over 16. But this is 4 over 1, right? So this will cancel with this. So what I get is negative 1 times 1, which is negative pi squared over 4. Hopefully this is right, but this is what I'm getting for the slope. And then I got my point, right? My point was this, pi over 4 and 0. Pi over 4, 0. So that's my point, and that's my slope. Did I get negative here? Okay, see if that's right. Then put it into the point slope formula and see if that's right.